Hello everyone. If you are taking the digital SAT, you have come to the right video. Today we are going to talk about two math questions that you absolutely don't want to miss. So let's begin. Okay, so the first question we'll cover today is from ratios, rates and proportions. So this one here says Natalie is planning a 250-mile road trip. Her car gets 32 miles per gallon on the highway. Note that this is a rate, right? 32 miles per gallon. Gas costs $3.50 a gallon. Again, this is also a rate. This is price per gallon. To the nearest dollar, how much will gas cost for the trip? So there is a road trip which is 250 miles long. Natalie is on that road trip. What we need to figure out is the gas cost for the trip. Now, because it's a cost, it would be a dollar amount. So we see a bunch of units. This is a rate question. We eventually need to come to a dollar amount, right? So let's just write down the units we have. We have 250 miles. We have 32 miles per gallon. And we have $3.50 for 1 gallon of gas, right? So these are some of the ratios or rates that we have. Now we want a dollar answer. So eventually, even if this is very confusing, what you're looking for is to get rid of everything else, miles, gallons, and come to a dollar answer. So first of all, what we need to think of is, in this whole trip, Natalie would need some gallons to go through the whole trip. So let's get to a gallon amount. Now we have a distance and we have a distance divided by gallons. If you divide this 250 miles by this number 32 miles by gallon, right? You can cross these miles and you would have a number which would be just in gallons, right? Because this is 1 by gallon, the reciprocal of that, you would have gallons. So this is equal to 250 by 32 gallons. So this is the number of gallons Natalie would use in her road trip. Now we eventually need the gas cost in dollars. We have a gallon amount and we have a dollar per gallon amount. If we multiply these two, right? $3.50 by gallon. These two get cancelled and we are left with a dollar amount, right? So the final number we will get is 250 by 32 into 3.5, and this is a dollar amount because the gallons got cancelled, and this is the answer that we are looking for. So let's bring up the calculator. So 250 by 32, and we will multiply it with the dollar per gallon amount, which was 3.50, right? So we get a number of 27.343. So what we are looking for is 27.343. So this is equal to $27.343. Now always remember to check, this is a student input response, so you need to check what is it really that the question is asking for. It is asking to the nearest dollar. So to the nearest dollar, this number would resolve to $27, right? So that's the answer that you are looking for. The second question that we cover today is on quadratic graphs. So let's look at the question first. It says the quadratic function f is defined by function of x equals 2 times x plus 2 whole square minus 1. Okay, so this is a quadratic function. If you already know this, it's in the vertex form. In the xy plane, which of the following could be the graph of y equals fx shifted 3 units to the right? Right, so a quadratic function is given and there is a transformation to that quadratic function. Now let's just recap some of the concepts so that we are very sure what this is talking about. Some of the things that you see from the options, 2 of the graphs are opening upwards, these two, B and C, and 2 of the graphs are opening downwards. Okay, and you see what the where the vertex lies in which quadrant. So these two vertex seem similar. This vertex is here, this vertex is here, and the y-intercept is same for these two and same for these two, right? So whatever information we can get, we would then be able to put it back and see which graph is the right answer. So there are various ways of approaching this problem. Let's look at one way to approach this problem. Okay, so let's just revise some of the concepts around it. So how do we write quadratic equations? We write them in the standard form usually, which is ax square plus bx plus c, right? And how do we know whether it will open upwards or downwards? If a is positive, it would open upwards. If a is negative, it will open downwards. The way to remember it is, for any polynomial that you see, the largest power determines what will happen at large positive values of x. So let's say we have an equation which is y is equal to x square plus x plus 1. As x increases, y is almost always influenced only by this term, right? X would increase, but x square would increase a lot, right? At x equal to 10, x is still 10, but x square is already 100. So y is largely determined by this number. So if x is very large and positive number and positive, then y will also be a very large positive number, which is positive infinity. Thus, if this value is positive, if the coefficient of x square is positive in a quadratic, it will open upwards, because as x approaches large values, y will approach positive infinity. And the reverse is also true. If there were a negative coefficient, y is equal to minus x square, as x increases, like, right? So let's say x becomes 100, this is minus 10,000, right? So as x increases, y is becoming more and more towards negative infinity. So just remember that whenever you see a positive coefficient, the graph is going to open upwards. Negative coefficient, the graph is going to go downwards. That was one concept. Maybe we'll just go back to the question and see if it helps us narrow down on our answer choices. So we see here the option, what is the a coefficient, right? So however this resolves, the a coefficient is positive, because this is positive, this is positive. So the x square is being multiplied by 2. So the a coefficient is actually positive 2, right? And we just discussed, then the graph, even if it is shifted to the right, it will continue to open upwards, right? So if we have even if this were the graph or this were the graph, and they are shifted to the right, they will continue to open upwards. So very clearly we can cross out a and d. Now it's really between b and c. And if you notice, the y-intercept is common, but the vertex, the lowest point for an upward opening graph, is what is different, right? In fact, even the y coordinate is the same, right? It's negative something, this is also negative something. Just the x coordinate is different. The x coordinate of the vertex here is negative, the x coordinate of the vertex here is positive. So all we need to identify is whether the x coordinate of the vertex is negative or positive, and we can zero in on the right option. Okay, so we can easily write quadratic equations in vertex form also. What does that do? It helps us identify what the vertex is. So the common vertex form is coefficient x minus h square plus k. If you see an equation in this format, that basically the vertex is h comma k, right? Where h is the x coordinate, k is the y coordinate. So for example, in this graph, the vertex is at 2 comma 4, and let's say a was 1. This graph can be rewritten as x minus 2 whole square, because h is 2, and remember the sign, right? Even though h is positive, the vertex form has minus h. So x minus 2 whole square plus 4, right? So this is the vertex form of this graph. Okay, that was one concept to remember. The next concept to remember is, how do we transform quadratic graphs, or any graphs for that matter? It's one way is you just remember this, but I'll also show you how to think about it intuitively. You could transform graphs in 4 different ways, right? So for example, if you have a graph like this, you could either shift it upwards, so it will become something like this, shift it downwards, so it will become something like this, or shift it left and right. If you shift this one left, it becomes something like this, right, it becomes something like this. And there's a very specific way in which these graphs are transformed. Let's look at right and left first. If you change x itself, if you subtract some value c from x itself, then it moves to the right. Slightly counterintuitive, but good if you can remember it. X minus c, then it moves to the right. If it's x plus c, it actually moves to the left. This one is a little counterintuitive, but I'll just try to explain this. The other two are fairly easy. If you just add a value to the function of x, right? Not do anything with x, but just add a value, it will move upwards. If you subtract a value, it will move downwards. If you forget some of this, and it's very easy to confuse and forget some of this, perhaps just draw y equal to x square and see how things will move. The easiest is, this is y equals to x square. If you just add some constant like +1, it basically means for every value of y, I'm basically going +1, right? So it will become a graph, something like this. Let me just make it again so that it will basically something like, so everything by +1. If you just make it y equals x square plus 1. What if you subtract -1 from y? It will just move downwards, right? So here y equal to 0, but if you y equal to x square is 0 at 0, but if you want to plot y equal x square minus 1, right, it will just move down by 1 units. Right, it will look something like this. It would have moved down by 1 unit. At this point, y is just down by 1. At this point, y is just down by 1. So every point it's down by 1. If you subtract 1 and if you add 1, it's up by 1. So this is more easy to remember. And if you can remember this, basically like left right shifting is when you don't change y but you change x itself, right? So let's think of it. If I am adding 1 to x, how does x change? How does this graph change? So I'm basically making it y equals x plus 1 square, right? Because the function of x is x square. So if I add 1 to x, it becomes y equals x plus 1 square. So basically what it now means is, for -1, right? If you put -1 as x, then it becomes 0. And at x equal to 0, x square was 0. So at x equal to -1, now x square is 0. If you have figured out the vertex, you can figure out that the graph would look something like this, right? So x plus 1 whole square is actually shifted to the left. And the inverse, if you have x minus 1 whole square, it would shift to the right. So the vertex would be here and it would have shifted right. So even if you forget everything, just try it with y equal to x square, you would figure it out. Or just plot these on Desmos. It's taking me time to plot here. You could simply plot it on Desmos and see how transformation would work, and then apply it to the question you have. If you forget all of these rules in exam, although I would highly recommend just remember these 4 rules, just go over them multiple times so that you don't have to do all this in the middle of the exam when time is scarce. Okay, so what all did we cover? We learned a couple of things here. What is the vertex form? If it's x minus h whole square plus k, then the vertex is at h comma k. And what are the rules to use to transform quadratic graphs? Now let's go back to the question and apply this. Right, so we see that this is very similar to a vertex form. Ignore what's here, a doesn't matter. This is h, this is k. So my h basically is -2, right? Remember, this is x minus h. If x minus h is 2, then h is -2. and this is plus k, so plus k is minus 1. So I know the vertex of the original function of x, which should be minus 2 comma minus 1, right? So something like this, minus 2 comma minus 1. Now it says we are going to shift it 3 units to the right. What does that mean? I basically need to shift this 3 units to the right. If you shift it 3 units to the right, this vertex will go from minus 2 to 1, right? So my vertex will actually become 1 comma minus 1, right? We had already excluded these two answers. So this is the only one that's a possible answer, because the shifted graph has a vertex at 1 comma minus 1. So B is the correct answer. Let's also look at one more way of doing this, right? So instead of going through all of this, what if we straight away knew that to shift the function we just need to change x? Okay, so what if we had just changed x? So let's say the new function is f prime x, or and that has a different x, right? So that has the shifted x. And if you remember, if you want to shift a function 3 units to the right, you're basically going to do x minus 3, right? So this would have become 2x minus 3. Everything else remains the same, so plus 2 whole square minus 1. This resolves to 2 times x minus 3 plus 2 is x minus 1 whole square minus 1. Now this is also vertex form. So what's the vertex of my f prime x, or the transformed graph? The vertex is 1, right? Because x minus h is x minus 1, so h is 1 and k remains minus 1. So with this also I know my vertex is 1 comma minus 1, so B is the only possible answer. Or what you could have done was just go to Desmos, plot this and just move it 3 units to the right. Now let me just show you how to do that. So let's just define the function first. Sorry. So f of x equals 2 times x plus 2 whole square minus 1. Sorry, x plus 2 whole square minus 1. But we are going to make a transformation, which is let's call it gx equals fx plus fx minus 3, right? Because we are moving it 3 units to the right. So you see the graph here, and let's go back. So this is what it would look like. Even from Desmos, you can be sure that this is the answer that you are looking for, B. Alright, so that brings us to the end of this video. Those were the 2 questions we discussed in this video today. If you like the channel, do consider subscribing it for more such videos. And remember, if you master the concepts, you can solve anything.